Hi, my name is Lee Janet. Now I'm going to talk about the introduction of the water tube in Beijing. The ambition of the Beijing Olympics was to be the Green Games, the high-tech games, and the people's games. In short time, since its opening, the water cube has become an icon of a new Beijing. The venue amazed visitors and inspired athletes at 2008 Olympic Games, hosting the swimming, diving, and water polo events. The design was delivered from competition stage through a fully approved scheme in just 12 weeks, with the fast-track program continuing through the official opening of the water tube in this year. Arup received a glowing tribute from the client, Thomas Yi, Vice General Manager of China Construction Design Institute (CCDI). With regard to Arup's performance on the project, we felt that Design Consortium did an amazing job. Arup team had deeply impressed the world by their professionalism, who delivered the multidisciplinary engineering service required for this key venue of the Beijing Olympics. The project was complete on time within budget. APM's judge agreed that the water cube made of worthy winner. Arup has managed to deliver on time and to budget, a truly inspirational and enduring project for the Chinese people within a complex technical and cultural management environment. By establishing a clear vision and roadmap that all stakeholders align to. Now I'm going to talk about the background of the building. Water tube located in Beijing. The Arup PTW architect and CCDI design was selected as a clear winner of the competition. The aquatic center was required to be the best Olympic swimming venue and then a popular and well-used leisure and training facility after the games. It was to cost not more than $100 million before the Olympics and $10 million for its conversion to legacy mode. The Olympics requires include a 50-meter competition pool, 33-meter diving pool, and a 50-meter warm-up pool. The main pool was to have 17,000 seats for the games and then be reduced to 7,000 seats with other facilities added in order to make the aquatic center a viable long-term legacy. The construction was started before the end of 2003 and to be completed at least 6 months before the Olympics to allow the sufficient period for trial competitive events. In 2003, the team of Arup, PTW Architects, and CCDI agreed that the aquatic center design should portray the way in which humanity relates to water and involves half of the available design competition period developing design with wave-shaped roof depicting the power of surf. Following the unveiling of spectacular glowing bird nest design of the National Stadium, Arup, just 4 weeks before the competition deadline, the aquatic center team realized their design could not win and made the difficult decision to scrap the wave design and swiftly agree the component parts of the water tube concept. The National Stadium is on neighboring site to the aquatic center. Two sites separated by protected history exist to Beijing Forbidden City. Factors that lead the team to develop complementary design to bird nests. They conclude that the cube concept would appeal to the typical Chinese way of understanding beauty design, representing the beauty and serenity of calm, untroubled water. The two opposing shapes sit together in harmony. The water cube is blue against the stadium is red. Water versus fire, square versus round, male versus female, and also the earth versus the heaven. I'm going to talk about the architecture of the water tube. Chris Boss. Chris Boss is a German-born architect resident in Sydney. He was key designer of the Beijing National Aquatic Center that was built for the 2008 Summer Olympics. He was educated in Germany and Switzerland. He worked with several high-profile European architects before he moved to Sydney. For many years, Boss has based his work on computation study of organic structure and resulting spatial concepts. His riches lies in the exploration of unusual structure, pushing the boundaries of the traditional understanding of structure and architecture with digital and experimental form finding. Chris Bosh's master degree deals with the implementation of virtual environments into architecture. The potential of naturally evolving systems such as snowflake, spiderweb, and also soap bubble for new building typologies and structures inform Boss work. The geometries in nature create both efficiency and beauty, but above all, the humans is the center of his investigation. Chris Boss also co-founded Lava, the laboratory of visionary architecture, with his partner in 2007. Lava has office in Sydney, Germany, and Abu Dhabi. As of 2010, Moses works as an adjunct professor and research innovation fellows at the University of Technology Sydney, UST in Australia.
Hi, I'm Lucas Ong from August batch. Welcome to my part, and now I'm going to talk about the biomimicry of the water cube, which is located at Beijing, China. So, from a view of the water cube, it designed like a solution for the exterior of the building because it comes from many shapes and combined together with square, pentagon, hexagon, and many kinds of it. Well, it looks like a geometrical puzzle, like an art of shapes for people to take some photos, leisure, and so on. I found that I was very far away from the first to become curious about this particular problem. And here I found a research for the solutions. In the late of 19th century, the great Lord Kelvin, the one who realized and solved the solution of shapes, and he asked about what is the most offensive way to divide space into cells of equal size with the least surface area. Between them, Kelvin himself proposed a highly regular solution to his own problem. But when we apply the 14 size Kelvin shapes, called a tetrahedron, it proved visually uninspiring. Nor was Kelvin the first to seek these solutions. A century earlier, a Bulgarian scientist, Petrov, had studied swap bubbles and devised rules for the way they join together in three phases forming a line. We call that 3D dimensions. Four lines coming together at the tetrahedral angle of 109.4 degrees. Surely it will be simple to create a geometry of a continuous array of swap bubbles? Yes, from Kelvin's answer, because surface tension automatically minimizes the surface. At this point, we again found a but, because Petrov's rules simply cannot be applied to create a geometry that joins together. This biomimicry can be played with the ETFE pillars, inside and outside, to gain the desired organic loss, which means the natural but complicated design, and to function effectively as an insulated greenhouse. So, this is the end of my part. Thank you for watching.
Hello, my name is Marco Lemongahen. I'm from FNBE August Intake 2014. The building that I've chosen for this assignment is the Water Cube. It is located in Beijing, China. I would like to talk about the design principles of the building. The design concept of the Water Cube combines the symbolism of the architecture and the unique water bubble structure and build an appropriate complement to the National Stadium. In addition to being an aquatic competition venue for the games, the center provides public multi-function leisure and fitness facilities before and after the games. The NSC functionally meets the requirement of 2008 Olympic Games and post-game operation. Now is the safety in design of the building, measured by international standards. Construction site safety records in China are poor. At the implementation plan workshop, ARUP's project management team made a strong commitment to explore the risk-prone activity likely to occur in the construction. The building design uses state-of-the-art materials to create a building that is visually striking, energy efficient, and ecologically friendly. The striking water cube structure is energy efficient by maximizing natural light and capturing solar energy to heat the interior spaces as well as the pools. Water efficiency is achieved by rainwater harvesting, recycling, efficient filtration, and backwash system. The exterior is made out of a transparent dual ETFE cushion envelope like bubbles, achieving great thermal efficiency. The water cube has more than 4,000 bubbles, the largest of which is 9 million in diameter, forming a building 177 meters square and 30 meters high. These air bubbles are relatively independent of each other, so they can be easily replaced. The LED lit bubbles allow warm water to enter the building and keep the water temperature at an optimum 28 degrees. But the air can also be stored and used in the water cube when required. EFTE is recyclable and light, but it is also strong, capable of bearing up to 400 times its own weight. As it lets in more light and is a better insulator than glass, it will produce energy costs in the water cube by 30%. The water cube structure consists of 3,000 pneumatic cushions ranging from with different sizes or from 9 square meter to less than 1 square meter in size. The water cube aesthetic is a pure expression of the design idea. A design which reflects a form of water, responsive to its physical and urban setting, demonstrating principles of traditional Chinese architecture and embodying latest technologies and materiality. Is result of cross-fertilization of ideas between cultures and between architectural and engineering disciplines. For this reason, this project is truly unique. The design sets a new precedent for engineering approvals for the Chinese Olympic venues. We are performance-based via engineering. The water cube as we know it would not exist. The building is the result of integrating the technical requirements of all the relevant engineering disciplines, not the results of a single dominant one. In addition, the building has outdoor and indoor air recycling systems, solar energy and double dash ventilation devices. The air conditioning system uses recycled hot water, and the designers engineered the airflow into the water cube to ensure the ventilation in the upper regions of the building was optimized. To help keep humidity at 50 to 60%, air ventilation systems at the lower end of the roof and in the facade of the building shell were also installed. Also, the pool depth is 13 meters, which helps to reduce the interference of water temperature variation. Okay, that's all of my talk. Thank you for listening. Bye.
Hi, my name is Lim Jason. I'm gonna talk about the structural design of the water cube. The structural design of the water cube is based on the most effective subdivision of three-dimensional space. The fundamental arrangement of organic cells and the natural formation of the soap bubbles. This naturally occurring arrangement contributed to this seeming random generation of structure, but it is in fact a solution that is extremely repetitive and highly buildable, removing the usual architecture inspiration that defines extreme geometry in buildings design, thus natural beats technology. Arup based the structural design on Trinity College physics professor Dr. Vier and Phelan's proposed solution to Lord Kelvin's conundrum: how would one tile an infinite array of cells in 3D shape in 3D space so as to minimize the surface area between them? The geometric shape of the building is based on a repeating unit which comprises two 12-sided polyhedron and six 14-sided polyhedron. This repeating unit is tiled infinitely in 3D space, rotated and then sliced about prescribed X to form the final building geometry. The entire building will be clad in ETFE foil cushions which have excellent insulation properties and will create a greenhouse effect. 20% of the solar energy falling on the building is trapped within it and is used to heat the pools and the interior area. The new technology that is used in this water cube, 3D CAD modeling used by Arup, was crucial in the creation of the water cube. Modeling the complex structure quickly, allowing for refinement and improvement in designs. The modeling and documentation of a building with 22,000 of steel beam members and 12,000 nodes was a fairly daunting proposal. This process was further compounded by the fact that we knew the structural optimization process was going to be constantly evolving and changing. Structure optimization program used in this water cube, Arup developed a structure optimization program which carried out the structural analysis, optimization and design. The iterative procedure would determine the optimum size of each member that satisfies all design constraints, resulting in the minimum structural self-weight. During the optimization frame, 22,000 steel beam members under 190 different load cases were tested. Its job was to test for possible scenarios challenging it to make the steel structure strong, but as light as possible. The benefit of an automated program is that it allows for the process to be repeated, allowing many design options to be considered quickly and accurately. CAD package conversion program. To guarantee that all the elements within the structural analysis model were imported correctly to the 3D CAD model, Arup created a conversion program run from within our CAD package. The program modeled the entire structure in 25 minutes rather than months if done manually. From that fully coordinated 3D CAD model, we were able to extract all of the elevations, sections and details to produce our final documentation drawings. Three-dimensional wireframe models were then made and saved to 3D AutoCAD electronic models. This allowed the clients and contractors to see many objects within the building with its relevant information.
Hi, my name is Lim Yang Kang. So today I'm going to talk about the dream feature of the water cubes Beijing, China. The water cube is designed to act as a greenhouse. Its ETFE culture allows high levels of natural laid ice into the buildings, and swimming pools are predominating heating drivers. They harness the powers of the sun to heat the buildings and cool water passively. This sustainable concept reduces the pool core energy consumption by estimated 30%. the system generating an effective negative U values of a net energy against the buildings. For these principles to work, the solar loss entering the buildings offset its heat losses. The use of thermal mass heat storage ensures that the heat the buildings gain from the sun during daylight is offset by overnight cooling. The thermal mass of the pool waters and heavy wet surface surrounding the pool effectively stores exist heat during the days and remits it at night, minimizing variation in load. Swimming pool centers are very conservative environments if not designed properly. So air distribution is critical. Due to this building unit failure, surface temperatures and air performance must be maintained to prevent corrosions. Nodes are located around the perimeters of the building to supply air up the wall. During winters, thermal buoyancy lifts warm air to the top. The reverse applies in summers, with cooler air being supplied to compensate for heat gains. This cooler air does not have the same buoyancy force, so it will not go all the way to the roof and only condition the lower parts of the buildings. This stratification of air also helps reduce overall energy consumption. The smart buildings is designed to be able to create a responsive, comfortable environment. Spectral areas, for example, air conditions by an under-seat supply system, which will only be switched on during the event. This targets the air conditioning and prevents wastage to areas not used by spectators and competition. Variations in shadings of the face have ensured the fabric heat loss are minimized in summers and maximums in winters, when the solar sun is more beneficial. This is achieved by patterning the various layers of the face when translator pans and by filtering the heat out of the cabins in summers and cabins in the winters. The positions and patterns of these translator elements have been implemented the response to the daylight and the thermal requests of the various buildings used next to the face. Energy consumption by the large pool is greatest reduced by using the displacement ventilation principles in the mechanical systems. The concepts of specifications in critical to achieve high-paced passive solar heat gains without generating large cooling loads. By allowing transmission air in this large space, the mechanical system needs only to improve cooling to the occupied space, reducing cooling loads effective by a force of 10. Air conditioning will keep not pools and office areas to around 22 degrees Celsius in summer times, with heat rejections of the air conditioning warming the pools. The less pools must be kept around 30 degrees Celsius, while the competition's pools requires 28 degrees Celsius. That's all for the green factor of the water cube Beijing, China. Thank you.